Hi, Algebra 1. We're moving on to lesson 6-4. And we are working with least common denominators. So you guys should know what least common denominators are, but we're going to give a nice little review right now. Our essential question today is, can you express two or more fractions with their least common denominator? So this is the type that you're used to as an example 1. Notice we have to get from 8 all the way to 32. So my question is, what did I have to multiply 8 by to get to 32? Good, we had to multiply it by 4. And remember that I can multiply anything through by 1. And 4 over 4 is equivalent to 1. So if I multiply the top and the bottom, we know that that's just multiplying by 1. 3 times 4 is 12. So the question mark here, we're going to answer it with a 12. Now, it's going to get a little bit tougher as we move to numbers with variables. So my question again is, what do I have to multiply 4y by to get to 12y cubed? Well, I know I have to multiply it by a 3. And how many more y's do I need to get from 1y to 3y? I need 2 more y's. So I'm going to multiply by 3y squared on the top and the bottom, because again, I can multiply anything through by 1, and it does not change the value. 7 times 3y squared on the top will be 21y squared. There's my question mark. As you can see, we are going to get into factoring. We still need to know how to factor. We're going to be factoring for a very, very long time. Personally, I like to show my little binomials together. So what would I have to multiply in the denominator? T minus 3 has to be multiplied by what to get to t minus 3 times t plus 5? Good. I'm going to multiply by t minus 5 over t minus 5, because once again, I can multiply anything through by 1. So remember that this in pink is equivalent to 1. And on the top, I end with t times t minus 5. And some of you would show that as t squared minus 5t. Unless it's stated in the directions to show it a certain way, I would take either one of these answers. So great job with that one. So the next set of questions is asking us for the LCD. Well, they're going to start us off easy, so we're going to have a little review here for middle school. Remember, to find the LCD, we're going to break down. I'm just looking at the denominator. I don't even have to look at the numerator because they're not saying don't deal with anything in the numerator. They're just saying break this down. Well, remember that this prime factorization is just 5 for 5. For 8, you guys know your perfect squares and cubes. You know that this is 2 times 2 times 2. And for 12, I know that this is going to be 3 and 4 is 2 and 2. So to find the least common denominator here, we do have to go ahead and take what's in common. So I'm gonna, you know what I'm gonna do? I'm gonna line this up. I have 5, and then I have 3 2's. And on the bottom, I have a 2, and a 3. And notice I'm lining it up all separately. So I'm looking at right here in this box right here, how to do this. So when I'm finding the least common denominator, I'm going to go ahead and circle the things that are in common, because if something's in common, we're just going to use it once. And everything else I have to circle and use once as well. So how many 2's do I have circled? I'm going to write the answer right here. I have 1, 2, 3 2's. I have 1 3 and 1 5. Well, 2 cubed is 8, times 3 is 24, times 5 is 120, would be the least common denominator of 5, 8, and 12. So I'm going to write 120 right here is the LCD. because all it did was ask for the LCD. Now it's going to get a little bit more difficult as we put variables with it. So we do want to pay attention to example 5. Let's star circle and highlight this one because we want to make sure we understand, leaving today, how to do example 5. Remember the first thing, everything had to be multiplied. So if I look up here at my example from what you guys have done before, everything was multiplied and we took what's in common. So the first thing that I always have to do is we want to factor first. So let's go ahead and factor the bottom. On this one on the left, I can take out a 2, and I have 2k minus 3. And on the right, I can take out a 3, and I have 2k minus 3. So if I was to take the time to see what's the same, remember what's the same, we're only going to use once. And so I know that 2k minus 3 has to be part of it because we're going to use that once. And then everything else we're going to use once as well. So 2 times 3 is 6, and I'm only going to use 2k minus 3. Now, like we did last time, if you want to go ahead and line this up, remember that we have 2 times 2k minus 3, and we had 3 times 2k minus 3. So it might help you to line it up again. We're going to use this once, and this once, and that is where we get 6 times 2k minus 3. All right, moving on to example 6. Let's factor first. We always want to factor first. I can take a 6 out of 6x minus 30, and I have x minus 5 left over. And it looks like I could take a 9 out, and I have x minus 5 left over. Ooh, and I need to know the common denominator. I like to just underline the binomials. Hey, this is going to be used once because I know we have 1x minus 5 in common. And then maybe with the numbers you need to break it down. Maybe you don't. Let's go ahead and break it down. 6 is 2 times 3. 9 is 3 times 3. So if I was to line those up, let's go ahead and do that over here. If I have 2 times 3 and 3 times 3, one of our 3's is used. And then I'm going to use a 2 and a 3. And remember, I had x minus 5, which was also in common. I'll go ahead and put that in here as well. So it looks like I'm going to do 2 times 3 times 3 times x minus 5, which becomes what? 2 times 3 is 18 times x minus 5. So it looks like my answer for the LCD is 18 times x minus 5, which makes sense because 6 goes into 18, 9 goes into 18, and x minus 5 goes into the x minus 5s. Great job. All right, the last thing we're going to do is we're going to look at this one. It's a little bit more difficult because they want us to rewrite the whole thing. So the left side, 5 over x plus 2 times x plus 3, is already factored for us. Don't touch it if it's already in those perfect little binomials. On the right side, I know that I could factor this. What are the factors of 4 that add up to be 4? X plus 2, x plus 2. Now we could write that as x plus 2 squared, but I like to see it that way, as x plus 2, x plus 2. So let's talk about what our least common denominator is. I'm going to draw 2 vinculums here. Okay, the thing that we have in common is we have 1x plus 2 in common. Do you see that? So we know that we have to have 1x plus 2. Now, we still have an x plus 3 and an x plus 2, so we need those as well. And I'm going to write them with x plus 2's together. So my common denominator, I use one of the x plus 2's together. I have to use all the leftovers once as well. So my common denominator is x plus 2 times x plus 3, because I need all of them. Now, my question for you is how or what do I need? If I multiply x plus 2 and x plus 3, and I'm trying to get to this x plus 2, x plus 2, x plus 3, don't I need one more x plus 2? I do, because now my denominators match. And again, remember I can multiply anything through by 1. X plus 2 over x plus 2 is equal to 1. And now this top is x plus 2, x plus 3, x plus 2, which is the same thing as x plus 2, x plus 2, x plus 3. Whew. So on the top here, I'm going to have 5x plus 10. Now, on the other side, let's see what we had to do to each side to get to our common denominator of x plus 2, x plus 2, x plus 3. Since this one does not have an x plus 3, I'm going to multiply the top and the bottom by x plus 3 because I can multiply anything through by 1. And I'm going to distribute this through. And so I get negative 3x minus 9 on the top of that side.